has a big impact. So let's start. I'm always concerned by these AI companies that start by, oh, we're working in a hospital, we have a ton of data. Let's throw it into a large language model and let's see what we can do. Yes. Let's begin with what is the unmet need. We don't have enough anesthesiologists, and actually in our hospital, and this happens, I know in the US also, an anesthesiologist is overseeing sometimes up to 6 operating rooms. If you think about it, and there's in the Lancet many studies, then the more operating rooms you're overseeing, obviously the risk for the patient increases. That there's, you don't need to do a lot of Lancet studies to understand that. It's common sense. So that was the unmet need. Then we have a lot of limitations on how the solution it is today. And I think a lot of companies need to be very humble on how your solution can integrate in all countries, in all resources, in all populations. We are a startup, we are a spin-off of a public hospital, and we've collected 4,000 patients of a public hospital in Spain. Would that work in Rwanda, in Nigeria? We don't know. That's the real answer, the humble answer. We're not saying it will not, but we will need to do validation studies to know that it works. How we constructed our data, and I think this is important. We constructed our data with anesthesiologists in real operations, during real operating rooms, with patient concerns, and we collected all the data of the different devices. Important, different countries have different devices. The less devices you have, as you can imagine, the less predictive capabilities you will be able to give. But some predictive capabilities probably is better than nothing, because at the end, the power of the predictive capabilities can come from the concentrations of the anesthesia drugs. Those are the biggest drivers of our predictive capabilities. So we spent 4 years only collecting data in operating room with anesthesiologists. And that's my other big advice. If you don't have teams in operating rooms that actually understand the disease that you're collecting data, I'm not certain that you know what you're collecting. Yes. As I mentioned, Pedro has spent, our founder, years at Stanford and MIT to know how to build databases. It's not that obvious to collect and create good databases that then can be a good base for a predictive capabilities. We actually, and that's also important, we do not use large language models. We have tried all large language model solutions. We do not use, the FDA and most agencies in Europe also, they will not approve a solution that is predictive in nature like ours in an operating room if you're using an LLM. Why? Because of the black box effect, because you will not be able to explain how you got to those predictions. So actually, once we collected all the data, these 4,000 patients, that is like 500 million data points, we then run it through our own predictive models. So our founders have spent all their years publishing in all the relevant papers about predictive modeling. So that's their core expertise. We're not relying in the expertise we have is not out there. We cannot use LLMs. We have tried. They don't have half the capabilities that we have, because that knowledge, you cannot find it in the publication world interconnected as we know how to interconnect it. Once we had the predictive models, then you have to run again, collect again, at least we did 500 patients, a new data set to validate that the predictive models that you built with the 4,000 patients actually now predict as you thought it would predict in the 500 patients. And currently we're undergoing regulatory approval. The data we have seen so far is that we can predict above 85% of the complications I was mentioning: hypotension, respiratory depression, noxious stimulus, so pain, and level of sedation. Those are the 4 parameters that we are currently undergoing regulatory approval. So as you can see, this is a very long process. We've been more than 5 years. We're still on regulatory submission. And I think the power that we have, and where I believe more in companies that are doing AI, is that they're actually working inside a hospital with real doctors doing real clinical practice, which is a difficult to do both things at the same time, but that you really understand the clinical practice, that you're not inventing tools that someone in some, I'm an engineer, that some engineers together thought, it would be a cool problem to solve. But in the daily practice, and then the other point that was made, in the daily practice, this needs to be in the workflow of the anesthesiologist.
Oh, we lost you. Okay, you're back. We lost you. Yes.
I was finished. So that is really how prediction works, and how we have taken into account how to build predictive models. We were very lucky that last year we were awarded by the United Nations for being the leader of AI for good in the healthcare space. And all these elements were the elements that they were taking into account. And we were very humble saying that does not mean that the way we have built this can work in multiple countries. What it means is that the next phase is let's do pilots in different countries with different data sets to make sure that it works in different countries, in different environments, with different devices. So this is just the beginning.
It's terrific. So could you just, I mean, since we're on in the technical realms of implementing predictive models in healthcare, in the model in the cohort that you developed and then you validated and now you're deploying the algorithms and it's working.
It's not. Sorry to interrupt. We're under regulatory approval, so we cannot deploy the algorithms. We're doing. Yeah. Right. Sorry. Apologies.
So eventually, when you do deploy it, right? Could you just explain or discuss with the group algorithm shift and what strategies you have in place to sort of mitigate that?
No, totally. So that's why the next step will be in multi-center, so in several hospitals in different regions, to collect another validation data set and then evaluate if the model is drifting or not drifting. And this will be part of our regulatory approval. We'll have a drift clause, which means we are going to have to be collecting continuously data, obviously anonymized data, to ensure that the models are not drifting. That no one will be able to, I believe no one will be able to have commercial predictive models without an eye on the drifting of the models. I also want to explain that whilst we're giving a window of predictions to the physicians, we're not taking away any of the devices that the physicians have. And this is very important, yes? So, and it's very important because if not, it becomes a nightmare of regulatory approval. So what we're saying is we are, dear panel, what is an algorithm shift? So, thanks for the question. So basically what it means is that maybe your predictive capabilities were very strong in our hospital in Barcelona, but we go to Nigeria, we go to Senegal, or we go to Vietnam, and we see that the predictive capabilities are not as strong in a new population or in a new hospital environment. That's the shift. The good thing is that our device, our software, it's collecting at the same time all the information of all the devices and our predictions. So at the end of the day, I can see if my predictions have shifted. If my ROC curves are 80% or suddenly they are 60%. And we will always do that in a clinical environment without doing a pre-validation to make sure that before I roll it out in your hospital, my predictive capabilities are at least 80 above. If they're not 80 above, it's not good enough of a threshold because that's our regulatory threshold. I hope that has explained.
Thank you. Thank you. It also happens that, that you also have shift even in the hospital where you developed it, right? If parameters change, practice changes, demographics changes, those kinds of things. Ms. Salami, sorry, Ms. Salami, let me go back to you and ask the question about what you consider are the most critical skills that healthcare professionals today need to be able to effectively work with AI.
Thank you for the question. And before I answered, I just wanted to say something because my assumption is that we all, when we talk about AI, we all understand what we're talking about here. But I will say that the sensationalization of AI really, came about probably over the last 3 years, right? When OpenAI released ChatGPT. And I think it's really important when we have this conversation, because she said she's not a doctor, I'm an engineer as well. Ms. Gubern just described is clearly, I would say, the operationalizing of like deep machine learning algorithms, right, into workflows. When we think about what is driving, like when the World Economic Forum is talking about adoption and value creation, we're now talking about generative AI, which is essentially these new models that have the ability, based on pattern recognition, to think. They're not human, but they can think, create and in some cases autonomously do things on our behalf. And I just wanted to state that is, so when I answer this question, ultimately, I'm answering this question based on these new models that are now flowing into what we'll call more agentic approaches, and at some point might end up being part of what we call the robotic intelligence, right? In healthcare. So that I just wanted to state that because I think it's really important. And I think that's probably where, when everyone thinks ChatGPT, Claude, that's really generative AI and agentic. And it does have a role to play in healthcare. So, and for clinicians. But when to get to the questions, there are three areas that I think are really important. One is really knowing what to ask. Clinicians don't need to be engineers. And quite frankly, the beautiful thing about the LLMs, which are large language models, the frontier models, the chat GPTs of the world, the Claudes of the world, and even Geminis of the world, is that you don't necessarily need to be technical in order to get value from them. But I think the clinicians really need to understand, again, I think I said this earlier, what can AI do and what can't it do for my specific problem and context? So radiologists using an AI-assisted imaging technology really needs a different level of fluency. And when I say fluency, it's not just understanding that it's AI that powers it or knowing the data, but a different way in which you use it and practice with it versus what a primary care physician will be thinking about when you're looking at just standard diagnostic support. The other part that I think is really important is just how do you evaluate the outputs? These models, and the reality is a lot of models that are being built now, a lot of the technology that are coming into hospital systems are powered by these large language models, right? So many of them are sitting on top of a chat GPT, or even at work, if you're using Copilot at work. And I just got back from Ghana 2 days ago. I was working with a couple physicians. Um, if you use Copilot, it's sitting on ChatGPT, right? So I say this because it's really important that we understand I would say the deeper science or math around like machine learning and the reality that we have a lot of AI slop with all of the other models that are now out there and driving the conversation. But critical evaluation of the outputs. You really need to treat any output you get the way you would treat having a second opinion. Or, so it comes out, you should be asking the same questions, what was the data that was used to generate this output? Were all of the right constraints, regulatory constraints, clinical constraints tied to my protocol, were those applied to this? Who might be left behind? Does this really look at the segments that typically are forgotten, right? How do we think about the social determinants of health and how that applies there as well? So I think that is really important that we have the skill set and remember that we are still the drivers of the technology. And this is where I talk about lead AI, not chase it. And then last but not least is workflow integration. They need to start thinking about in my work today and where I have a lot of friction, what parts of my work must I own and must I continue to maintain to make sure that my patients have the best quality of care that leads to the best outcome? What parts of the work are okay for AI to either start, and again, I'm talking about these models that can think, do, create on our behalf, and what role do I play in verifying? And then last but not least, what parts of my workflow really can be truly automated, where human intervention or my intervention doesn't really matter as much. So I think that's kind of what I would say. It's know what to ask for, understand, ask the right questions, really evaluate AI. For those of you who have used whether it's Claude or ChatGPT, know that you get very confident answers that might be wrong. So remember that. And then last but not least is think about it from a systemic standpoint so that it scales appropriately.
Thank you, and thank you for really hammering on the point of differentiating large language models from predictive models that use machine learning, which is all AI, of course. You've talked about some of the problems, even with the best large language models today. And I think Eva, talked about transparency and black box issue. Ms. Salami, could you talk about other